Howdy, 7th grade. Today we're going to look back at something that we've talked about before. This lesson is designed to be kind of a review of this thing called proportional relationships. And when we hear proportional relationships, sometimes it's also called direct variation. And if we remember, direct variation is any time we have two variables that follow a certain pattern. So what it is, quick definition for review, is that we need two variables. I'm going to call them x and y that work with y equals k times x. So it's anytime we have two things and we can find one by multiplying the other by something. So y equals k times x. And this k here is called the constant of proportionality. So when you see that, you can think k is for constant. I know that's not how you spell constant, but you know, math people made it up. We can't always spell too well, and that's okay. So if we graph one, this is something that we seemed to get the hang of pretty quickly last time. So if we graph a direct variation, it will always be a straight line. So what it will look like, a straight line, and not only that, it will go through the origin, so the middle part of our graph. And the reason for that is if we go up to our equation here, right there, if x is 0, anything times 0 equals 0, so y would also have to be 0. So no matter what k is, no matter what our constant of proportionality there is, we will always have that point where y is 0 and x is 0 as a possibility, because anything times 0 will still be 0. So what that should look like, just for those of us who maybe are more visual, would be that right there. This would be direct. And if we had anything else like this, or maybe a curved line, both of these would be not direct. And just to make it very clear, if I have a graph that is curved but goes to the origin, it is still not direct. It has to be a straight line that hits the origin. That makes it a direct relationship, direct variation. So some places where we'll see these, just for review, if where we see these. The first place we see these is anywhere that has anything to do with ratios. So anything with ratios, and that means like if you're talking about how many miles per hour something goes driving down the road, if you're talking about how much money someone gets paid, anything with ratios, you're going to see a direct variation. And that's not the only place you'll see it. You also see it in geometry. So some places you'll see in geometry is a lot of relationships there. So perimeter versus the height of a square, for example, would be a direct variation. And we'll see these actually a lot. So again, what we want to look for is if we are given an equation, y equals kx is direct and everything else not. And just for a few examples, if I have, let's do circumference equals 2 pi times the radius, because I have my essentially y here. This whole thing becomes my k, and my radius would be my x. My circumference is equal to something times my radius. This is direct. In contrast, if I have something that looks more like y equals 3x plus 5, this is not direct. And if I have y equals x squared plus, we'll just leave it as x squared, that is also not direct. And this is not direct because we have the squared there. This is not direct because we have the plus 5. So what we need is one variable equals something times another variable. If that's something we get, then it's direct. And an easy way to figure it out is to graph it and to look for this graph right here. So this graph is going to make us happy. That's all for today. It was a bit of a review. I hoped it was stuff that we mostly remembered, and I will see you all in class tomorrow. Have a great day.